examples for you on antiderivatives, and let's go ahead and get started on these. So there's usually clues and there's usually reasons why teachers and professors write problems the way they are, because we're trying to apply definitions in a pattern. And this one is no exception to that. So I have a numerator and denominator, and at first glance they're thinking, what do they have to do with anything else? But again, going back to one of the previous problems, step number one is look for the derivative of something that is on the inside function, like this, what we may substitute in for u. So when we take the derivative of this right here, of x to the third plus x minus 5, all right, that's going to be 3x squared. That's going to be my constant of 1, all right, because it's just, there's no other thing in front of it. And of course that becomes 0 because that's the slope of m equals 0, so on, okay? So what I have here is, again, this is my dx, my derivative of this part right here, the inside part. So I'm going to employ u substitution again, and instead of going through it step by step, I'm going to go straight to where I substitute this in with the equivalent of what dx is. So I'm going to have dx solved for, and I'm going to substitute this in for my u. That's going to be my inside part. We typically substitute u in for some part that's in parentheses, usually raised to a higher power. Sometimes it's in a square root, sometimes it's in other things. So here's my u substitution. I'm going to substitute in two places. When we do u substitution, we substitute in two places. So I'm going to let u equal to x to the third plus x minus 5. And I'm going to let dx equal to, and I've already took a couple of shortcuts here, 1 over, and I'll explain it, 3x squared plus 1 du. Because when I take du over dx of this, and I multiply by dx, divide by 3x plus 1, because this is my u. So when I take the derivative of this, I get this right here. So when I solve for du, I get this. So I substitute in two places. I substitute right here, and I substitute right here. Here is my new integral with substitution. I'm still going to have the 3x on the top, all right? I'll do it step by step. They're going to cancel out. But I'll go ahead and do this one last time and show you how they cancel out. All right? And this is going to be u to the third power. So I'm in violation of a few rules here. And this right here is just 1 over 3x squared plus 1 times du. All right? We're treating it like a fraction. Well, of course, this and this cancel out. So what I really want to do is go from here to here in basically one step. So I'm going to have my integral, and I'm going to have 1 over u to the third du. There you go. All right? I'm going to take the antiderivative of 1 over u to the third of the du. Now I can also have written this like this, because our power rule, I could have written it like that. And I can use my reverse power rule by adding 1 here and dividing by whatever that is. And let's go ahead and do that. We're going now to finalize it. We're going to take the antiderivative at this stage. So I add 1. That's -2, and I'm going to divide by -2. All right? Let's go ahead and write that answer out. So this is all equal to u to the -2. That's plus 1 right there. So that's going to be u to the -2 over -2. U to the -2 over -2. We don't like our answers with negative exponents. So we're going to have this as -1 over 2u squared, and plus my constant of integration. This is my answer in terms of u. We need to get in terms of x. So we're going to resubstitute in. So we're going to have -1. That u is nothing more than x to the third plus x minus 5 to the third power plus my constant. All right, so that is my final answer on that one. Again, Eventually, you're going to go from here straight down to here and just eliminate that, eliminate the x term, so on, get everything in terms of u, take your antiderivative, then resubstitute in. Critical step, though, is to recognize you have the derivative in your problem. This one is also going to be u substitution. So let's take a look at this. So I look at the bottom and I go, aha, look at the top right here. All right, so if I were to do the bottom again, I would have x squared minus 2x plus 5 here. I'm going to take the derivative of this. That's going to be 2x to the first minus 1. Okay? Let's see. Minus 2. Yes, we got a problem here. So that's minus 2. All right? I should have worked this out ahead of time. I didn't. I got overconfident. All right, so that's 2x minus 2. But if I do this and I factor out a 2, I get an x minus 1. So we're going to have to do that. We're going to have to factor out that 2. So let's go ahead and do that. So we're going to let u equal to x squared minus 2x plus 5. All right? And that means when we let dx, we're going to have that basically over 1. So we're going to let dx is equal to 1 over 2x minus 2. Well, I just wrote it with this right here. So I could have factored out that 2. But I got to write the du right here. All right? When I substitute for u substitution, I'm substituting for this, and I'm substituting for this, apparently. All right? So I'm going to have this over u. These are going to cancel out when I factor out this 2. That 2 is going to have that, well, 1/2. I factor out a 1/2. This is nothing more than 1/2 times 1 over x minus 1. All right? So I'm going to factor out that 1/2. That can go all the way to the front. In fact, let's go ahead and write that 1/2 all the way to the front. Okay, so I'm going to have 1/2 integral. And again, I didn't do every single step because this is my third or fourth example on u substitution. We have something like this now. Again, this represents this bottom part right here. And when I replace this, that x minus 1 is on the bottom. Those cancel out, and I'm left with the 1/2. I move that to the front. Well, we've seen this before on a previous example, I think on the first set. This is nothing more than the natural logarithm of u. So what we have here, when I put the answer out, I'm going to take the antiderivative. I have 1/2 ln of x plus my constant of integration. As previously discussed, we have a domain issue. We want to make sure that we extend the domain to both sides of the graph. So we're going to resubstitute in what u stood for, the function, the natural log function, absolute value of x squared minus 2x plus 5 plus my constant. And I could bring that 1/2 underneath, so I could have wrote it like this. Let's put that in parentheses just to be a little bit more precise. 2x plus 5 all over 2 plus c. All right, so this one is, either one of these would have worked. Okay, so that's pretty much it. Just to recap, I recognized again I have the derivative in the problem of down here, as long as I factor out that 2 in the denominator, which comes out to be 1/2 in front of my function right here, or my operation. Okay, so I'm going to go ahead and get these two posted and see if I have time for a third one, but probably not.